Welcome to The Explainer. We're here to break down the complex ideas shaping our world, and today we've got a really interesting one.
You know, state-of-the-art generative AI is just incredible, right? But it can also be incredibly slow. Whether you're generating video, making high-res images, or just analyzing a huge document, you've probably felt that frustrating wait time. Well, it turns out that a huge part of that slowdown comes from one specific process. It's a thing called attention, and it's at the very heart of how most modern AI works. It's the magic, but it's also the bottleneck.
So what if we could fix that bottleneck? What if we could make the whole process way faster? But, and this is the key part, without making any compromises on the final quality. Today we're diving into a research paper that claims to do just that.
All right, so let's get into it. To really get what's going on, we first have to understand the problem they're trying to solve. Why is this attention thing so computationally heavy in the first place?
Okay, check this out. This is what's called an attention map, and it basically visualizes how an AI is thinking. Every single one of those dots is a calculation where the model compares one piece of information to every other piece, and it has to build a map like this just to generate one word or one frame of video. The number of calculations is, well, it's just massive.
And that leads to this huge issue called quadratic complexity. It sounds technical, but it's simple. If you double the length of your input, say your video resolution or your document, the compute time doesn't just double, it quadruples, it explodes. And that's exactly why generating really high-quality, long-form content takes forever.
So how on earth do you fix a problem like that? Well, the big idea here is a concept called sparsity. And really, it all boils down to a very simple, very elegant idea. Just do less work. So SpargeAttention is all about being smart. It's about looking at that huge attention map and figuring out which of those millions of calculations are actually important, and which ones are, well, basically zero. The goal is to find all those useless calculations and just skip them, without hurting the final result, of course.
But here's the real challenge, and this slide shows it perfectly. The way an image model pays attention looks completely different from how a language model does it. They have totally different patterns. And most of the older methods for sparsity were tailor-made for just one of these patterns, which meant they weren't universal at all.
And this brings us right to the first major innovation in this paper, which is called SpargeAttenn. They came up with a really clever, universal way to predict which parts of that attention map are safe to skip, no matter what kind of AI model you're dealing with. So here's how it works, and it's a really neat three-step process. First, it breaks the data down into little blocks and checks how similar the stuff inside each block is. If a block is really repetitive, it gets compressed down into a single summary. But if it's complex and full of detail, it gets left alone. Then, it uses that quick compressed overview to predict which of the full detail blocks are actually important enough to spend time on.
And the magic word here is selective. It's not just blindly compressing everything. It intelligently looks at the data and says, okay, this part is simple, we can summarize it. But this part over here, it's complex, so we have to compute it fully. This is what allows it to be both super fast and super accurate, no matter what kind of data it's looking at.
But they didn't stop there. SpargeAttenn has another trick up its sleeve, a second optimization that's basically a free speed boost.
So while the main computation is happening, it does another check on the fly. It's constantly asking, hey, is the result of this next calculation going to be so tiny that it's basically zero? And if the answer is yes, poof, it just skips it. It's pure, ruthless efficiency. And here's the best part. This check costs nothing. It happens right on the GPU in parallel with all the other work that's already going on. So it adds zero extra time, but still manages to cut out even more unnecessary calculations. It's a total win-win.
Okay, for image and video models, SpargeAttenn has one last innovation, and honestly, this one's my favorite. It's a really clever geometric trick.
So think about it. An AI usually processes an image the same way we read a book, left to right, line by line. But an object in an image, like a person's face, isn't organized in neat rows. Its pixels are all over the place, which can make it harder for the AI to see them as one coherent group.
So what they do is, before anything else, they reorder the pixels. Instead of a simple row-by-row scan, they use this thing called a Hilbert curve, which traces a path through the image that keeps neighboring pixels together. It's like pre-organizing the data to make it way easier for the AI to spot the patterns. And the payoff for this is huge. By grouping related pixels together like this, that selective compression we talked about earlier becomes way more effective. You get more blocks that could be summarized, which means more sparsity, which means more speed. And, critically, the final image is exactly the same. No loss of quality.
So when you put all three of these innovations together, the smart prediction, that free GPU speed boost, and the clever Hilbert curve trick, how well does SpargeAttn actually perform? Well, the results kind of speak for themselves.
On a cutting-edge video generation model, they saw an end-to-end speedup of almost 2 times. That means a video that used to take, say, half an hour to make, now takes about 17 minutes. And again, with absolutely zero change in the final video quality.
And this wasn't just a one-off. Look at these numbers across the board. For a language model like Llama, it's over 4.5 times faster. For video and image models, massive speedups. And the most important column is the one on the far right. In every single test, the quality was perfectly maintained.
And really, this slide says it all, doesn't it? On the left, you have a frame generated the normal, slow way. On the right, the one from SpargeAttenn. They are visually identical. You can't tell them apart. That's the whole story. All the speed with zero compromise.
This kind of work is so important because it doesn't just make the AI tools we have today a little bit better, it fundamentally unlocks new possibilities that were just too slow to even be practical before. So you have to wonder, what new things become possible when our most powerful AI tools suddenly run twice as fast?